Hey guys, so Jason Matthew here from Trinidad and Tobago. Welcome to our new segment, Biochem Bloopers. Remember, we are not here to criticize, but we are here to learn from other people's mistakes. So the question today is on the topic of enzymes, and specifically we're going to be looking at energy profile diagrams. So if you think you're not familiar with energy profile diagrams, I will recommend that you go and just read up a little bit about it. It's there on the Biochem GM YouTube channel under Enzymes, part 1. You can look at it there, check your textbooks and so on. But if you think you're ready, let's get started. So the question today is this: with the aid of an energy profile diagram, explain how an enzyme catalyzes a chemical reaction. Alright, so remember, just in case this is your first one that you're looking at here, pause for a cause. Alright, do not rush to see what the answer is. You try to answer that question on your own. Alright, so if you have to go back and look and write down the question, fine, do that. Then go to the podcast, go to your textbooks, but you try this question on your own before you go forward. Alright, so let's just reacquaint ourselves with the question. With the aid of an energy profile diagram, explain how an enzyme catalyzes a chemical reaction. So please guys, you do this on your own. Right, so the first thing here is that, people come out the exam, thinking, well, I wrote a lot, I am sure to pass this exam. Well, I have been marking papers for a while now, and, I sometimes get full booklets, pages upon pages written, but there's just nothing there that is worth any marks, right? So don't be fooled about that. Just because you think you write a lot doesn't mean that we're just going to give away marks like if it's Christmas. It doesn't work like that. We have a marking scheme and we have to stick to that. Alright, so this person here, well, first of all, it's an energy profile diagram, and you should be able to know how to label the axes. Now this person, I guess they were choosing an endothermic reaction. I will assume that's what they were thinking. I mean, I didn't specify if it's an energy profile diagram for an exothermic or endothermic reaction. So it's fair game. If you want to do an endothermic reaction, that's fine. Alright, but look at how this person did their arrows. Alright, it's activation energy, or if you want to refer to it as free energy of activation. It's up to you. I would say activation energy. So they had the right concept that an enzyme will lower the activation energy. That is correct. But the diagram is way off. There are many mistakes here. So for instance, alright, they have from 0 to up here is delta G. We'll see just now that's wrong. Alright, it's from the reactants to the products. Alright, from the reactant to the highest peak is what activation energy is. But they have, again, from the products to the highest peak. So that is wrong. So this is actually a common error, that people don't know from where to where is the activation energy exactly. They know that the activation energy is being lowered. But sometimes on an energy profile diagram, they get a little trouble to identify which is which. So please guys, just pay attention to this. Well, this person obviously had no idea what's going on. They got the free energy on this axis part correct, but rate of enzymes, I mean, come on guys, even you should know by this writing that something feels wrong. And then I can't remember anywhere any notes having a shape of graph looking like this. Alright, so there's things to wonder about. Now another problem, and I mean, we need to think about what we're doing. If you want to show me that the enzymes are lowering the activation energy, then you need to put the two curves on the same graph so we can compare them. This person has one graph here with the curves separated, and you have to assume that the axes, I guess the scales are the same, and that this one is showing a lowering of activation energy. But that is very, very poor sense. You need, anytime that's basic maths here, people. When you are comparing two curves, you put them on the same graph, the same axes. Now this here I don't know. I think they were going for a Michaelis-Menten curve. That's what they were thinking, but that is definitely not an energy profile diagram. This person, again, the students have some trouble in identifying exactly where the activation energy is. So, you know, you have to be very careful how you label your graph. This person was, I don't know, they were on something else altogether. All right, so this is definitely wrong. So if you have something like this as your answer, know you're going seriously on a wrong path. And speaking of wrong paths, this one here definitely has no idea what an energy profile diagram is. So I put this one in just to show you all that it's sometimes a miracle that I'm not an alcoholic at the end of the semester, because I see some answers like this. Right, so this was something that I'm hoping that those who are listening have something similar to this. All right, now a few things. You need to label your axes properly. So your y-axis should be labeled free energy. Your x-axis should be labeled reaction progress. Some of you might say extent of reaction. All of that is fine. You are always going from substrate to product. If you're looking at a chemistry textbook, they might have the word reactant here. It's the same thing. It's just in biology. When we're looking at enzyme catalyzed reaction, we call the reactant a substrate. So you're going from a substrate to a product. So label that properly, right? Substrate, product. Now you see in this diagram here, they make sure they show you the level, the energy level of the substrate, and delta G double cross, or in other words, the activation energy. It's from the level, the energy level of the substrate to the highest point of the curve. All right, so you make sure and have that clearly, right? It is from the energy level of the substrate right up touching the highest point of the curve. And the next thing, to either do like a key where you have different colors for your lines or for your curves, or, you know, like in this case, you have a -1 representing the catalyzed reaction. And as you can clearly see here, the activation energy for the catalyzed reaction is much lower than the activation energy of the uncatalyzed reaction. That is clearly shown in this diagram, and that is what you want to be going for. All right, the next thing here now is the delta G, change in free energy for the reaction, and that's the difference between the energy level of the products, energy level of the substrate. So again, you have to be careful with what you're labeling, guys. You know, we as the people who mark in your papers, we're going to be looking for that specifically. We want to see that, you know, it's from the level of the substrate to the highest point in the curve will be activation energy, and you know the level of substrate to product is delta G, or the change in free energy. Alright guys, so that's basically it. Also, just showing the definition for activation energy. What is activation energy, people? Correct? It is the minimum amount of energy for the reaction to occur. So if you all had this graph, excellent stuff, guys. Keep at it, you know, keep studying. As usual, guys, you know, we really appreciate your support. If you like what's going on here, please press the like button and subscribe to the YouTube channel. Look out for more videos coming soon. Take care, guys.